would like to welcome Dr. Peiying Zhu, the Senior Vice President of Wireless Research at Huawei. She will be talking to us about 6G, the next frontier of wireless innovation. Dr. Zhu is an IEEE fellow, and she's a fellow of the Canadian Academy of Engineering. She is currently leading 5G and beyond wireless research and standardization within Huawei. The focus of her research is advanced radio access technologies. She is actively involved in 3GPP and IEEE 802 standards development. She has been regularly giving talks, many of them with us, luckily, panel discussions on 5G and beyond 5G vision and enabling technologies. She led the team to contribute significantly to 5G technologies and standardization. Dr. Zhu serves as the guest editor of the IEEE Signal Processing Magazine special issue on 5G revolution and IEEE JSAC on deployment issues and performance challenges of 5G. Prior to joining Huawei in 2009, Peiying was a Nortel Fellow and a Director of Advanced Wireless Access Technology in Nortel Wireless Technology Lab. She led the team and pioneered research and prototyping on MIMO, OFDM, and multi-hub relay. Dr. Zhu has more than 200 granted patents. Thank you so much for joining us, Peiying, and please.
So I just like to one more thing. She was a speaker as well in Toronto 5G Summit 2015.
Yes.
So we had Jan, you were there. A lot of people. So I just want to acknowledge that. Yeah. And you were the co-chair there.
Yeah,
right?
and she came back in 2019 as well. Thank you so much, Peiying. The floor is yours.
Thank you very much. Okay, thank you for inviting me for the talk, and I know it's very kind of late. I will try to be brief. So I will talk about a little bit about what we envisioned for 6G and what are the challenges. As many of you already know what are 4G, 5G, but we think what are two major aspects are driving the development of 6G. One is the intelligence machine, such as robots, and the other one is the advancement of the AI technology. And these two actually will drive us to rethink how we want to provide a service using our 6G system. In fact, if you listen to one of recent talk from Elon Musk, his claim that in the future this electronic vehicle it will turn to actually robots on the wheels, and the truly autonomous driven car is not feasible without solving the generalized AI problem. I hope that's not true, but it seems that's the case. So we think that given those important driving facts, we think that we will, for 6G, we will move from the connected things actually to connect intelligent things, or in general, we think it will connect intelligence. So the two important new services are related to the of AI as a service and of sensing as a service. We all are very familiar with 5G's definition or usage scenarios, and we see this will continue to be improved as you hear the previous speaker Monish gave an excellent topic about the issues related to the millimeter wave, and we believe that with the evolution of the technology, we hope that we can solve this problem within the time toward the 6G. So we'll have a further enhancement or improvement of technology to serve better for the what we envisioned for IMT.VISION and all these services. But the most important things on top of that, we want to open the new market for the new generation, and the two things I mentioned that are the keys. So we added these two as a new category, which are the AI as service and sensing. So if you look at the all this category, even with the evolution of the 5G, we hope that 6G will solve some advanced use cases which are not feasible in 5G, even though it might be envisioned in 5G. But on top of that, we see the new use case add on top of that with AI as a platform to offer the tool for the enhancement of the network and the system performance, and in addition, as a service for data management and the distributed learning and inferencing. And with sensing, we can envision even more applications such as the high accuracy localization tracking and simultaneous imaging mapping and the localization and all the other augmented human aspects. I'm not going to go through all the details of these use cases, but you are welcome to look at one of our white paper has a better description on each of those use cases. Then what we see the 6G capability, essentially we see 6G has 6 key capability. One is what we call the native AI support. Essentially, this has 2 aspects. One is we use AI as a tool to improve the wireless system performance and also to automate the network management and so on. The other more important aspect is we see the 6G is a network actually to provide the AI as a service, in the sense we use this as a platform to offer the collaborative learning and collaborative inferencing. Then second one is a network sensing. So this, we basically use the network as a sensor so that we can sense the environment and every intelligent object or intelligent machine need to be able to perceive what's the environment and the surrounding. So sensing actually essentially provide a mean for us to see the world. Then also we can sense the information to help the communication itself to improve the performance of the wireless system. Of course, the connectivity is still the most important things for wireless system, and we envision 6G will further enhance the connectivity so that we can offer fiber-like link performance, and also this will allow us to better serve the Industry 4.0 and beyond. Then the fourth point is, I think Slim mentioned about the unconnected with satellite and HAPS and those non-terrestrial system. We see the integrated system with non-terrestrial and the terrestrial system so that we can actually provide this service for the unconnected populations. And the fifth point is that we believe that 6G, the trustworthiness is one of the key points, especially considering that we were also dealing with the data in addition to the connectivities. So we need to have the privacy, security, and resilience these built in, and on top of that, we see 6G will be a more open system. We will have probably more different players to run the system, and so that we need to have a better multilateral trust architecture to build in to support this kind of activities. Last but not the least, we need to think about how to build a system at the beginning to think about to provide the low power consumption and low EMF so that we can be a contributor to make a sustainable network, and not only the network itself, but also enable the other industry to be power to reduce the power consumption and so on. So particularly for the enhanced communication part, we envision the more immersive communications, so that you can not only just have the voice and the video like today, but we also be able to have the more kind of a human touch type of applications of communication, so that you can maybe feel and even feel the not only the touch, also the smell, sense, and all those things. Then for the industry application, we envision that we will have more and more, as I mentioned, the collaborative robots operating together to perform the complex task. So we will be able to enable those type of use cases, and in the health industry, we hope that we can help, aging population, and so that we can make people's life live better. Yeah. So to do that, of course, we need to have a better, capable systems in terms of data throughput and reliability, and also the connectivity. If we have more and more, not just a population, but more if we have those kind of devices to serving the individuals. So in terms of sensing, actually what we are looking is reuse the communication radio signal to use that to sense the environment. So this can actually, we're hoping that we don't use the same hardware, same equipment, and without additional spectrum to do that. And this will allow us to enable the application I mentioned previously. And one of the reasons we think this sensing is really will be more useful in 6G is that the fact that we're moving toward a higher spectrum, which give us a higher sensing capability in terms of detection resolution, or the imaging resolution, and so on. Of course, we envision that we will use multiple spectrums in 6G, not just the higher spectrum. As a matter of fact, one of the important band is probably somewhere in the centimeter wave, which is a range between 7 to 26 gig area. But since we typically operate in the multi-band, so actually naturally we can have a multi-resolution sensing system, so that we can see the large scale area and also zoom into the details. Okay. So in terms of the native AI, actually one of the things we see the issue going forward, like today's cloud AI mode, is the concern on the data privacy. Probably most people don't want to transmit the raw data to the cloud. So if we build a distributed learning architecture, so that we can actually do some local learning and send only some intermediate data to the cloud, so that we can preserve the privacy. This will maybe alleviate some concern on the data privacy. And also, the more important is that actually moving the data to the cloud, consuming lots of power. So if we keep the data closer to the source, then hopefully we can have a better power efficient learning architecture. Similarly, for the inferencing, because our device actually have a different computing capabilities, so we can build a system so that take that into consideration, so that we can look at the this or learning or inferencing taking consideration the computation capability, and also the power efficiency capability, power consumption aspects, and looking at the communication bandwidth aspects, then put these together, trying to figure out a better way to arrange those inferencing. So if we combine the sensing of this capability of obtaining the data itself, plus the distributed learning capability, these things actually combining together, we can see many new business opportunities. So in summary, what we see the 6G network is that we have a very different kind of devices. All of these devices will have different sensing capabilities. I was talking about as we're speaking, and there is a ITUR 6G vision workshop yesterday, and people are sharing their thoughts on what 6G should look like. And this is some of initial, thinking in terms of usage scenario for 6G. As you can see, there are 6 usage scenario. This is quite similar to what I mentioned before, but except there's one global coverage. This is be emphasized on the usage scenario D. And also in the middle, there's a discussion on the user trends. And you can see the linkage between usage scenario and these trends. So I think with the collective efforts, I'm hoping that we can manage to have a more agreed version of vision of 6G in the middle of next year. So I will stop here, and if you want to see some more details on the 6G, including the enabling technologies, you can look at one of the book we published last year. It's available on the market. You can get it even on the Amazon. And also there is a website, you can search in the 6G technologies. So we have some of prototype demos on the website. You can see some of enabling technology we're trying to verify to support some of this vision I just mentioned. Thank you very much. Yeah.
So Peiying, we have one question in the chat. What are the products or solutions that you see emerging from connected intelligence?
So what we are thinking is that we will be able to offer the services so that people can utilize our platform as a learning platform, so that they can actually tell the network what they want, and they can they utilize our either pre-trained model or we have be able to managing the data source or managing the data, so that we can offer the learning opportunity. Of course, we can also help the clients or customers so that they can obtain or managing their own data. So that's one thing, a learning aspect. Of course, so if we once we learn, then we can offer people to do the inferencing as well. So we see this actually, you can use this as a joint communication and computing platform to do those kind of things. Yeah. Of course, we can also offer the native service as well. Yeah.
Thank you. Another question: what is the difference between connected intelligence and federated intelligence or federated learning, in your view?
I think federated learning is one particular technology, but connected intelligence is a more general term because we can not only just use the federated learning, we can also use the other technology like split learning, horizontal, vertical learning, all those things. I think sometimes there are many new names, even in the academia, talking about the same things. Here we just use. We also one thing I think I want to make sure we have some emphasis on this federated learning. We need to consider the aspect of the wireless connection, which are not reliable, and also there's a mobility aspect as well. So when we think about we use a mobile device to do the federated learning, then you need to think about how to handle the aspect of the devices moving. So it's a slightly different from some typical federated learning. Yeah.
Thank you so much. So Peiying, we have like a token of appreciation. We'll get it to you when we see you next time. And with that, thank you again.
Thank you.